Hello to everyone. Thank you so much for joining, registering, and being with us here today. I'm Yuval. Together with me here today is Asher. We're both from Deep Tech Showcase, and we are joined by our very special guests from Eviation Aircraft. Gregory Davis, President and CEO, is here with us today. And in case you weren't sure which event you've joined, it's here on the screen for you. Welcoming the electric aviation revolution. A bit about Deep Tech Showcase. It's not the main focus today, but for anyone who's never been to our events, who's never heard of us, who doesn't know why we've been sending them so many emails over the past couple of weeks, Deep Tech Showcase, as written here, we are an active ecosystem that supports the growth and development of deep tech and dual-use technologies. Our members include founders of novel technologies in many different industries, government stakeholders, corporate decision makers, and venture capital firms. One of the fascinating companies in our ecosystem is in fact Eviation. And that leads to amazing events like we're gonna have today. And obviously Eviation is in the aviation industry, which is a very big industry for us. We run many different events. This event is going to be fantastic because we have a fantastic guest here with us. But there's another fantastic event happening this week, which will also include Eviation just by chance. The Aerospace and Defense Showcase is happening this week. We host a different event every month with a different topic. And just by chance, January 26th, 1 p.m. Eastern, we'll send a link to that so people can attend. There'll be many different panelists from government, VC, commercial, and that should be a really, really great event as well. But focusing on today, I'm going to pass over the mic to Gregory Davis, President and CEO, Eviation Aircraft, and the floor is yours.
Thank you very much. Look, I'm very excited to be here. I'm just going to bring up my presentation.
Sure. We'll let you know when we see it, and then all is good.
Very good. Okay.
Fantastic.
Excellent. Okay, so if you can see that now, look, thank you all very much for coming today from wherever you are. I'm certainly very excited to share the story of aviation with you and tell you what we're doing and why we're doing it. There's no better way to start than what I'm about to do, which is I'm going to show you a video of our first flight. On September 27th of 2022, Eviation made history by flying the world's first all-electric commuter aircraft. And what you just witnessed is just a short version of that meaningful event. It really was aviation history. And what's amazing about what we did is it's not just about flying an airplane that happens to have, electric motors and a battery system. That aircraft demonstrated all of the technology that you need in order to make an electric airplane fly, in order to make it marketable. For the aviation folks here in attendance, what's amazing about that flight is not only was it the first electric commuter aircraft flight, it was also the first time a Part 23 aircraft flew using fly-by-wire flight controls. So that in itself is quite an amazing achievement. We're very, very proud of it. And it just shows you how real and immediate our solution is. This is available. That plane flew today using today's technology. We're in a world right now where aviation currently makes up about 3% of all CO2 emissions. And the International Civil Aviation Organization actually projects that's going to increase to anywhere between 25 and 50% of global CO2 by 2050 if we don't change things. Noise pollution, anyone who's lived near a large airport understands that there's a presence felt whenever an aircraft comes into takeoff, or for that matter, land. There's a challenge that we face from an aviation industry perspective in terms of acceptable noise. And then we're in an environment now where aviation fuel obviously continues to increase in price. It's a major contributor to the total operating cost of any aircraft. And we haven't had a meaningful change in aerospace technology in decades. So this is the environment that we sit in today. And there's all kinds of factors that are pressing against the aerospace industry. So obviously, people aren't willing to tolerate noise in their backyard. The world understands that there is a real problem with global warming and that carbon emissions continue to make it worse. It's not a question anymore. We have to do things about it. Things like advanced weather patterns associated with climate change, the very real effects that we're seeing globally, they're bringing a lot of attention to the aerospace sector and what we're doing in terms of carbon contributions. And we've seen changes in the likes of the government of Norway bringing forth regulation to bring in zero emission aviation by 2040. France banning certain short haul aviation routes inside the country, anything that could be otherwise done with greener transportation like electric trains. And then other factors, Amsterdam Schiphol and restrictions that they've put on their airport operations. There's a lot of headwinds that are actually going against the aviation industry right now. And when you look at short haul aviation in particular, the dirty secret is that it's pretty much the worst carbon polluter per mile traveled of any form of transportation. Okay? This is today's environment. In the United States alone, there are 200 active airports that operate with noise restrictions. And that means that you can't fully use the airport infrastructure. Either it closes down, in the evenings, or even the way that the aircraft's approaches and departures are controlled are affected by these regulations and how the aircraft are allowed to operate. And so here's where we come in. At Eviation, we've found the sweet spot for electric aircraft, right? We're part of the sustainable aviation industry, and our focus is on bringing electric aircraft to market. And what that means is that we're actually producing an aircraft that's going to work in what we call the regional air mobility market. So it's short range, fully electric travel. Our aircraft has no tailpipe. It literally produces no specific emissions. When it flies, there is no carbon generated. Because it's electric, at idle, when the aircraft's on the ground and waiting to take off, it produces a very gentle whooshing noise. It's very, very quiet. And moreover, as aircraft people, we understand that you can design quietness into your airplane. So we're doing this as part of our go-to-market. The electric propulsion, it's the first new propulsion technology in 70 years since we went from the Super Constellation piston-engined aircraft to the 707. It's the first time that we've seen this change. And what this allows us to do is we can go and eliminate the fuel costs associated with flying the aircraft. So electrical energy derived from the energy grid is much cheaper and frankly also much cleaner than energy derived from jet fuel in flight. And this is what we're bringing to market. Also, electric motors, they only have one moving part. So the maintenance on an electric motor versus the maintenance on a hot section on the turbine is substantially small. And that means that we're the first of a new generation of aircraft. Our plane's designed to have a maximum operating speed of 260 knots true airspeed, which is actually a regulatory consideration. And I'm going to expand a little bit on why we're doing what we're doing. We're going to have an entry into service range of 250 nautical miles day VFR. And for anyone, again, from the aerospace industry, we at Eviation, we've chosen day VFR to express our range because it's the most broadly comparable expression of range that you can have in any environment. So anywhere in the world, 250 nautical miles day VFR is pretty much the same number. It's a 9-passenger aircraft. So the base configuration of the aircraft is going to be designed for 9 people, and we're going to have a useful load of about 2,500 pounds or about 1,100 kilograms. That means that you'll be able to have 9 passengers on the plane with their laptop, with their trolley bag, their weekend bag, and fly your full mission profile. So we're going to change up the way that we fly. Okay, this is something that we are going to do that hasn't been done really since the dawn of aviation. And let me explain how we fit in, and I'll expand a little bit on the sweet spot. So I will say that our business is about what we call the 3 C's. It's about carbon, right, which we've explained. It's about cost, because what we need to do is make sure that the solutions that we're bringing to the marketplace are usable, that we can afford them, that we can afford them as passengers, and that we can actually adopt them in a broad scale so that we can make the difference we need to make in terms of carbon pollution. And then it's about convenience. So you'll see how this all ties together in a moment. Half of all of the world's air travel is less than 500 nautical miles. And regionally, so depending on where you live in the world, anywhere between 20 and 30% of the flights around you will be actually 250 nautical miles or less. So this is a market segment that currently exists. These flights operate every day. There's probably one flying by you right now. It exists. It is a current market. Now, what's happened globally is we have lots of airport infrastructure around the world, but we don't use it. And so the airports that were built, 30, 40, 50, 60 years ago aren't being leveraged in the way that they were originally intended to. And so we've evolved to a hub and spoke model, which is primarily driven by cost and by a shift to larger aircraft, right? So again, longer range aircraft, larger aircraft are, shall we say, less expensive per passenger. Their costs per seat mile are lower than a traditional small airplane. And so airlines have naturally gone to where they can control their costs. And then we as passengers, the general public, have gotten on board. So we've got this bus model where you hop on and you go to wherever the bus station is, and then you figure it out from there. And we're going to allow this to evolve back into the taxi model. So we're going to go from the bus to the taxi. You're going to get on an airplane where you want, and you're going to fly where you want. And this is what we're going to evolve back to. By going in and producing an efficient short-range aircraft, we're going to enable a cost-effective shift back to convenient travel. So what we're highlighting here, we're using the United States as a good example of where this technology can be applied, but the same does actually apply in Europe and Asia. We've seen the regional connectivity drop decade over decade, really year over year for 4 decades now. And for depending on where you are, so I'll use just a random example of maybe Milwaukee. So Milwaukee to one of the Chicago airports, right? The frequency has decreased. Now most people actually just have to drive to Chicago, and it's a large metropolis, right? So this is what's happened, and the same patterns repeat itself over and over again. And in the United States alone, there are 5,000 airports. 5,000 airports, and about 95% of the population of the country lives within 25 miles or about a 25-minute drive of their nearest airport. However, about 90% of the population actually has to drive over an hour to get to the airport so they can get on a flight. Okay? It's because we're not using the infrastructure. Of that 5,000 airports that currently exist, 2,000 of them are what the FAA would call underutilized, and really only 500 of them actually get full service. And as I said, of those 500, 200 of those airports are also operating with noise restrictions. So there are a lot of underutilized resources in terms of the infrastructure. And when I describe what we do, and as I will now, we have found the sweet spot for electric aviation. Okay, so again, looking at the total available routes in the United States, in Europe, and in Asia, Australia, I mean, there are so many things that you can do with this aircraft. Let me just break down the sweet spot for you. So we're a 9-passenger aircraft, okay? 9 passengers is on purpose. 9 passengers is the limit that you can have for paying passengers with a single pilot for operations in North America and Europe. Okay, so going back to the cost element of what we're doing here, by keeping it to 9 passengers, we are able to fly with a single pilot, which reduces the operating cost of the airplane. Now, the plane will have 2 pilot seats, so that means that you could fly with 2 pilots if you wanted, or you could have your fully licensed airline transport pilot flying in the captain's seat, and then actually have a trainee pilot learning how to fly the airplane in the co-pilot seat. Right, so you can do this, and it will help you build an ecosystem of pilots, right? Which is also very important because we are in a global pilot shortage right now. Now, the next part of the sweet spot is actually the certification standards we're using for this airplane. So, as you can see, it's an airplane, right? I'd like to say, 80% of the plane is just a normal plane. And what that means is that we're actually certifying the airplane using the existing regulations for certifying a commuter category airplane. We don't have to go and reinvent the wheel. We just fit it into what's currently there. The next part about that is also how you operate the airplane. So again, it's a conventional takeoff and landing aircraft, which gives us the benefit of aerodynamics so that we can optimize our energy utilization on the airframe. But the airport infrastructure already exists, right? So again, as I said, 5,000 airports in the United States alone. So we're going to fly the airplane. We're going to take off from an existing airport. We're going to fly it through existing airspace. We're going to use pilots that were trained in the existing systems on an aircraft that's certified the same way that any other commuter aircraft is certified, right? So that's where we've converged on the sweet spot. So economically and also from a certification perspective, it really fits into this niche. We have the edge on the marketplace. So first off, going to cost. Our direct operating costs are projected to be anywhere between 30 and 80% cheaper than comparable aircraft, right? So this is where we're targeting the market. The majority of that, again, comes from the fuel cost. So with aviation fuel, you're looking at a minimum of about 3 times the cost per kilowatt or kilowatt hour than you would have from an equivalent grid-derived electrical energy. And again, the savings on the motor of the aircraft are going to be substantially lower as well. So no hot section inspections. We'll have a battery that's designed for the right amount of longevity so that you can optimize your energy density and your cost, which I'll speak about again in a minute. Look at some of the markets that we've got right now in North America and in Europe. So starting with the inner circle, the darker purple circle that you see, this is going to be our entry into service range for the aircraft. So 250 nautical miles. I'm gonna talk about some customers in a moment, but I'd like to use Cape Air, which is an East Coast United States well-established regional airline. It provides regional connectivity and essential air services. They operate a fleet of over 100 aircraft, 9-passenger aircraft. And when we looked and worked with them about their routes, and we've gone and done our route analysis, they could replace 80% of their flights with Alice the day it enters into service. Okay, now obviously it's going to take us some time to build up many airplanes, but there's a direct usage case. So 80% of their existing operation could be transferred over to a fully sustainable electric aircraft on entry into service. And then as the battery technology expands and enhances, which is, again, very, very exciting advances in battery technology to talk about. But as this grows, we'll be able to then retrofit the aircraft with the newest batteries. The aircraft's being designed for that. So that means that your performance will continue to increase. So one fun fact about Alice is that just through the planned battery maturation, the aircraft will actually get better and better as it ages, right? We'll get more range or more speed out of the aircraft as those batteries advance. So in terms of our competitive edge, where are we? Okay, so first to market. So no one else has flown a full-scale electric aircraft, right? We are ahead. Now, I'm comfortable saying that we're about 3 years ahead of what we can see in the competition. And that's through our own analysis. Obviously, we keep track of what's going on. But also, we have conversations with our customers and our supply chain. And that's what we're hearing as well, is that we are indeed ahead. And one of the reasons why is because we've really focused on developing batteries that can be certified, right? So our battery technology, we've demonstrated the core technology, the architecture and the software for our battery when we did our first flight and the testing running up to it. We're also very purposeful about designing a product that's exciting. So we want you to be excited when you get an Alice, right? So when you're going on your family vacation, you've got your kids, maybe your dog, and you're hopping on the airplane, you're going to go away for the weekend. We want you to want to get onto this airplane. So we're being very careful of making sure, very purposeful of making sure that the aircraft is beautiful and comfortable inside and out. Our approach, we're not building a vertically integrated, do everything ourselves, I think we can be best at everything company. What we're doing is we're focusing on our key areas, which again is electrification of flight. So custom built, purpose designed electric aircraft. And then we're going to work with the global supply chain to find the best partners for bringing the aircraft to market. So the best partners in structure, the best partners in avionics and electrical, the systems, the integrated systems like the fly-by-wire system, again, the flight controls, and of course, electric motors. And we're very lucky that we're working with the leader in the industry right now, Magniex. And we've got a really tight relationship that's allowed us to, we feel, move faster than other organizations. And then, of course, the best training and avionics solutions. Now, the other thing that we've done very early in our program is we've engaged with the regulators. So we've been working with the FAA in particular for years at this point to make sure that they understand what we're doing and how we're approaching the design of the aircraft. We feel that's actually helped the FAA in terms of decision making for building the regulations that are then going to be used to certify electric airplanes in general. It's also been helpful for us to be able to validate our approach on battery design and other aircraft systems integration decisions just by working with the FAA and understanding how the product will be certified. Battery leadership is key. Okay, so nobody builds aircraft batteries, at least not integrated systems, and so we've had to advance this technology, and we've learned quite a lot over the past several years to the point where we were able to obtain the flight permit and safely fly our plane. The key approach that we've taken is we've divided our battery into different subpacks, and each of those subpacks is able to perform at the system level voltage. So we're using an 800 volt system. And these are then integrated through a series of computer controls and contactors. And what it means is that we're able to effectively isolate the energy storage, so the amount of energy we have available from the power it produces at the motor. So we can control each separately. And that makes certification of our battery system and our electric motors that much more akin to certifying a typical fuel system and motor system. Now, as with the rest of the aircraft, again, going back to the sweet spot and what we're doing, every system of the airplane is intended to be certified using the existing regulations, and that includes our batteries. So we've been very thoughtful about how we're integrating our battery design, our battery certification approach into the Part 23, Amendment 64, the commuter category. There are three different versions of the aircraft, and we're going to talk about that. But one thing that they have in common is they're all inspiring. So when we went to market, what we found was that there's a real desire for the commuter aircraft, that 9-passenger plane, again, to go and replace those existing routes with the aircraft that we've got. The other thing that we found, of course, and we'll get to customers again in a moment, but DHL has been very vocal in their support for Eviation to use the aircraft as a cargo plane. One of the great benefits, of course, is it's got a plus size cabin for the typical size of the aircraft, right? So having to design the aircraft around the batteries has led to some very interesting conclusions, one of which is that the cabin is actually larger than you would get in a conventionally powered 9-passenger airplane, simply because of the volume needed for the battery integration. But every element of the design of the aircraft has been done with an eye for style. So again, we want you to be excited about flying on it. We want to be inspired, and we want it to be a very cool and fun experience for people, and of course comfortable. So the commuter category, this is going to connect communities, right? Again, looking at that map of the US or the map of Europe or the world, the point-to-point air travel. I mentioned before, I'm in Arlington, Washington, which is just north of Seattle. You can think of 9 people who would want to fly from Arlington to either Vancouver, British Columbia, or Olympia, or even the SeaTac. I'd be able to find 9 people any minute of the day who are about to make that trip. So I mean, the usage cases are quite extraordinary, to the extent that when we've gone to market with the aircraft, we do a market study for every one of our customers, and we look and say, okay, how are you going to use the plane? Which routes will it work on? And where are you going to deploy the aircraft? And what we found is that in many cases, we've gone into a discussion for an order for maybe 15 airplanes, and then after having run the usage case, we've ended up with an order for 30 airplanes, because people see much more opportunity than even they were expecting when they approached us. So there's a real demand for the commuter variant of the aircraft. The other one, of course, that we've already placed in the market is the cargo version. So the cargo configuration, again, package freight. So similarly to the comfortable experience you're going to get as a passenger. Again, because of the volume created in the cabin and by accommodating the batteries, you actually are able to have more space for package freight. And when you look at how the aircraft in this size are used for that last 100 miles of package delivery, packages have actually gotten quite light, right? So the density of those, Amazon packages or other overnight deliveries that we're used to getting, those boxes are less dense. They have less stuff in them than we used to have in the days of consolidated shipping. And so by changing over to an aircraft like Alice, well, we can ship those less dense packages, but we can actually fit more of them in the cabin, which means that your aircraft will be better utilized than an existing plane that runs out of space for things. And again, you're going to be able to do it with no carbon emissions. And then finally, the executive version of the aircraft. So going back to so some of the cultural aspects of what we're seeing, there is a real desire for people to be able to maintain personal connectivity. And for a lot of people, that means, I'll say it, for some lucky people, that means access to personal aircraft. And in the same way that we are able to bring an experience that will allow us to get from point to point on our trips, we're also developing an executive version of the aircraft, which will be marketed to, or is being marketed to, corporate flight departments and people who can afford to buy a plane. Again, we're going to make this a luxurious experience. I do expect you're going to see some of these showing up in other fleets that we'll be able to gain access to as well. So maybe the occasional splurge, but there is a demonstrated interest in this aircraft, and so we've expanded it. So what you can see in terms of going to market, there's a replacement market for the aircraft where we can go and replace the existing piston or turbine powered planes flying short range routes. There's a growth market, so the application of the new technology, the electric plane, to expand markets like cargo. And then there's an expansion market, which is people are looking at the aircraft saying, hey, wait, well, this aircraft actually is the exact opposite of the planes I have right now. It's designed to be most efficient operating at lower altitudes over short ranges. So again, exactly the opposite of what you typically get from a turbine aircraft. And it means that we're seeing lots of growth potential in the market beyond simply going in and replacing what's currently there. The customer roadmap right now is actually very broad. So when we've done our market studies and we've said, okay, well, who do we believe would be a prime candidate for operating the airplane? And there's a number of fractional ownership companies that are expanding into the marketplace right now. Depending on where you are, there's companies like Jet Suite X, which you'll see flying around regularly, Surf Air, Wheels Up. These are companies that are in the public eye, and they're offering an improved experience for flying, right? So again, the ability to connect, to make a short trip, to go and see people, to see family, to make a work trip, or ultimately just to make your day more convenient. And these companies are growing rapidly. What we see is an opportunity to work with them to make sure that their growth is also zero emission. And that's where, again, our aircraft fits with them. The cargo proposition is clear. Again, the reduced operating cost, and then the ability to penetrate into the marketplace using a quiet aircraft. And then, of course, the private operators and corporate flight departments. There's a lot of ESG, so environmental sustainability initiatives that are being presented by large corporations. Again, our aircraft is a perfect fit for those corporations so that they can continue to operate their business the way they like, but do it in a sustainable way. And then we're also seeing interest from airlines, from Part 21 or scheduled air operators, both to provide premium service, again, operating feeder services from small regional airports to major airports, and also to supplement the existing network to provide new connectivity options. Again, our aircraft, it's a 9-passenger plane, which means that it does have commercial applications, right? As we discussed with, well, I guess all of the examples I've just given, but large airlines are actually starting to see a way to integrate it into their network as well. So in terms of where we are, our order book, so we have letters of intent signed for over $3 billion worth of orders at this point, and that continues to grow. Since our first flight in September, we've more than quadrupled our order book. So that's a relatively short time period to expand so rapidly. We've got more than 300 aircraft on order with customers. This is it means that we're going to have the ability to scale our production line accordingly. Cape Air is in for 75 aircraft. We're very excited to be working with them. They've certainly been a leader in terms of the push for sustainable aviation. Global Crossing out of Miami, Eviation Aero is actually, they're starting a new sustainable airline in Germany. And through our discussions with them, they're actually able to generate a new business based on technology and aircraft such as Alice. So you can see again the expansion potential for the marketplace. I could talk for a long time about DHL and how important our relationship is. We're both very proud to be working with one another. We at Aviation, of course, are very excited every time we see a DHL booth at a trade show, because there's always an Alice represented there. The Northern Territories Air Service in Australia, again, it shows the geographic diversity. So with this, we've got Northern United States, Southern United States, Europe, and of course, Australia. And then now Aris in Mexico, of course, is starting a service. So again, lots of opportunities for regional connectivity. And then also very important, of course, is Air New Zealand. So New Zealand as a country is a thought leader in terms of sustainability. And with that goes their national flag carrier, Air New Zealand, which is also a tier 1 airline who've been very forward and working on ways to advance sustainable aviation. And so for us, it's a real honor, and we're very proud to be working with them and to have been selected to help transition their fleet. So we fully expect that you're going to see Alice flying and operating regional connectivity routes in New Zealand within a decade. Again, very exciting. There's more to come on the sales side. So more announcements are going to come through. You'll see a couple of very interesting ones that we can't quite talk about right now, but certainly a lot of action. So, I know there's a lot of people online here, and I see a lot of questions. So I'm going to wrap up shortly and leave the door open for some questions here. Just want to take a moment and sort of recap here. So Alice is the sweet spot. We've found the right way to deploy electric technology to aviation. Regional air mobility is our future, right? Is the way that we're going to be flying in the next 10 years, the way we're going to be connecting. And just to emphasize why we're doing this, we are able to transform the way that people are going to live and travel. So going back to the utilization of the network of airports that we've got globally. It's going to benefit smaller communities, right? People who otherwise wouldn't have immediate access to air freight or air travel are going to be able to go to their local airport and fly. And we're going to be able to do that because it's a zero emission product. So you can add those flights without worrying about harming the environment. And it's going to be cost effective because of the other benefits of electric technology, the reduction in operating costs, which makes for a convenient way to travel. So I like to say, that I've got 3 kids, I have 3 young children, and I'm just looking forward to, when they're young adults, being able to take their families on those weekend trips. They're going to be doing it in electric airplanes, but the technology by then will be so mature that the fact that the plane's electric won't even factor into it. People won't even know. So this is where we're headed. The QR code here, if you scan that QR code, it immediately places an order for 10 airplanes. No, I'm kidding. It's a contact code for reaching out to us. So please feel free to scan the code. You'll get our contact information for any questions beyond the session. But otherwise, thank you very much. I'd be very happy to start answering any questions.
I think I'm going to start. But then again, if there's any, just so you know ahead of time, Greg, if there's any questions you want to cherry pick first, feel free. Otherwise, I think I'm going to go chronologically. We don't have, right now we have over 57 questions, just for the members of the audience, just so they know. It just became 58. So we're probably, unfortunately, not going to be able to make it to all of them. So Greg, I'm going to start asking, and maybe even either Javier or you can cherry pick a few other ones. But the first one is, what is the range / duration of Alice?
We're going to enter into service with a 250 nautical mile day VFR range. So again, the reason why we use day VFR is because you can, other forms of other ways of identifying range have different factors like reserve factors. So it's 250 nautical miles. Now that will increase as we bring out upgrades to the aircraft associated with the advancements in battery technology. And on that note, we're seeing some very exciting things on the battery front. I mean, NASA's got a roadmap for a 500 watt hour per kilogram solid state battery. There's other companies, one out of Australia that's got a lithium sulfur battery that could actually leapfrog the technology roadmap that we've been using thus far. So again, very exciting, and all of that will integrate into the airplane. And then here's the thing. So with the way that people use aircraft the size of Alice, the average flight duration is 1 hour. Okay, so ours will fall into that same category, about 1 to 1.5 hours of flight. And somebody's going to ask this, so I'll answer it right now. We're designing the airplanes so that you can charge 1 hour of flying time and 30 minutes of charging time.
That was actually, you covered the next question.
Okay.
The next question,
yeah.
What is the DC fast charging level Eviation requires, and are you guys developing a charging network already?
So yeah, I mean, it's going to be a megawatt charging system. There's different approaches that could be applied when we finalize what we're doing here. We are going to be providing a charging infrastructure, so at least the ability to, we'll be providing chargers to add to the airport infrastructure. Now we see there's a few different ways that this is going to roll out. So local airports, municipal airports, or larger airports are already coming up with their electrification strategies. So in terms of getting power to the airport to charge aircraft, I will say that technology exists. I mean, if you go to any movie theater or department store, pretty much anywhere in most countries now, you're going to see a bank of at least a few vehicle charging stations. It's a similar scale to what we're going to require for charging airplanes. So that part exists. We'll be providing chargers. We'll also be providing the ability to get a mobile charger, right? So that means that you can charge call it an e-Bowser or a charging truck, maybe even off airport or at some part of the airport, and then go in and deposit that charge or transfer it into your aircraft at a different location. So we can decouple, being tied to a specific charging point or a stand, and have the airport services provided that way. So there are a few different options that we're going to be providing.
All right, perfect. And so that was awesome. The next question is how does Eviation maintain fire safety while ensuring a high enough battery density?
Right. So the aircraft's designed from scratch around, again, certification standards, which ultimately are safety standards. Right. So with respect to the lithium ion batteries that were used in the prototype aircraft, and which are certainly the best candidate for entry into service in 2027. We use a hierarchy of battery management software and sensors. Right. So we manage from the entire energy system down to the subpack level, down to the cassette level, which makes up the subpack, down to the individual cells. So we're able to track and monitor the health and condition of every single cell in the battery system at all times, several thousand times a second. And with that, the software is able to make decisions about how to keep the battery healthy.
Perfect. Awesome. All right. The next one. These are really technical. Just a heads up. Do you gear to the propeller, or is it a direct drive?
Sorry.
Okay. What efficiency gain do you achieve from running rotational power to rotary output?
Okay, that's a great question. That's an email me afterwards and we'll talk question. But so the short version, it's a direct drive, right? So one of the interesting things about the electric motor and the way that they're structured is that you can actually turn efficiently. Right, to your question, you can turn with electrical and mechanical and thermal efficiency at appropriate prop speeds. Okay, so then you also have the option of either using a traditional governor or an electric, call it direct drive, for selecting your blade pitch, which doesn't quite answer your question, but I think you can see where I'm going with that.
Sure. And then the next one's also a little technical, but it seems like someone who's a fan, which is awesome. Would love to know some of the reasons for the redesign of Alice from 3 motors to 2.
That's a great question. So for anyone who can go and Google it, you can see the aircraft that we presented at the Paris Air Show in 2019 actually had 3 electric motors. So one mounted behind a V-tail, and then one each mounted on the wingtips. One of the reasons why we needed 3 motors was because there was a limit to the available power from the motors at the time. So in order to propel the 9-passenger aircraft, with the loads that we would need to do, we needed 3 of them. And in time, those motors have now they've doubled in power output. So that means that we really only need 2 motors at this point to achieve our performance target. So that was actually the main driver, was that the advancement in motor technology allowed us to make a more conventional design of aircraft. And then also, when you go back to that sweet spot, it's going to be, frankly, easier to certify a conventional configuration aircraft than to provide a certification or go through certification for a more novel configuration. So technology of evolution and the ability to bring the product to market.
Awesome. All right. I'm sorry. There's more technical. So you're having a very technical Q&A. But do you anticipate a ground-based battery cooling system while charging?
Yes.
Okay.
Yeah.
Perfect.
Yeah. Anything over 150 kilowatts, you're going to need some kind of forced cooling. So that's for the motor, and also when you look at actually managing your charging. So.
All right. Perfect. Do you see a future where you're adding wireless charging to the planes, and do you expect extended range in the future? I'd assume yes.
Yeah, so I'll answer the second part first. Certainly, we will be able to extend the range, but I'm going to say only to a point. Again, look at the way the aircraft are actually used, right? So our market segment, so that 20 to 30% of flights that are less than 250 nautical miles, those flights are made in aircraft the size of Alice. So there's going to be diminishing returns to expanding range beyond a certain point. But on the same note, you look at the range. So range is directly proportionate to energy. So you add 10% more energy to your system, you can use that. Well, the math doesn't quite work as a reserves, but whatever. Too technical. There's a direct relationship between range and energy availability. But as the batteries start to really evolve, we'll also have the ability to make the aircraft go faster.
Awesome. That's awesome. All right. And this question's really blunt, but someone in the audience asked if you guys are raising.
Yes, we are. So if you're interested in that, I'd be more than happy to have a conversation for you. But I think it's known there that we're in a Series B right now. Yeah.
Yeah, and also just to add on that, feel free to use the QR code that's directly to my email, and I will put you in touch with Greg and his team if you email me. So feel free to use that QR code. Okay, back to the technical questions. Will the reduced number of passengers make the ticket prices increase? Meaning, because you're not running a 200-person flight, is it going to be more expensive per ticket regionally than, let's say a larger kind of flight?
Okay, thanks for that question. So again, 9 passengers has a very special significance, right? So you can operate a single pilot plane. It's a short range aircraft. The operating costs are going to be much lower from electrical energy than from burning jet fuel, especially as the regulations evolve and it becomes more challenging to sustain jet operations from a financial and regulatory perspective. So the easy answer is that all of our market analysis that we've done, in conjunction with our customers, has showed that the aircraft will be economic over short ranges with the number of passengers we have on board. So you'll be able to afford flying on it.
All right, and then the follow-up question is actually connected to this. I mean, it's a different attendee, but with more taxis than buses in the sky, what are you thinking about the crowded regional airspace? So is it going to be, yeah?
That's a great question. So again, with the electric aircraft, so there's a replacement portion of the market, and then there's going to be growth. The airspace as it stands right now and the airport infrastructure is dramatically underutilized. So it will be a long time before we have to start worrying about overwhelming the airspace. Also, the airspace technology continues to advance as well. So automatic controls, things like aircraft signaling. So I think we're in good shape there. I will say that the general aviation market in the world is about 50,000 aircraft, and there's about 35,000 aircraft in service at any time. The replacement market for an aircraft the size of Alice is about 4,000 planes. So there's about 4,000 aircraft that fly equivalent missions to what we're doing. So we're not going to go and double the total general aviation market. But we are absolutely going to replace and then augment the existing short range market. So again, I can see your point, but compared to the overall aerospace network, tremendous success on our part will not overwhelm the network on their part.
Awesome. And this question might also be an email question, but is there a backup system or a redundant system in place in case the electrical system fails?
Yeah, so that's a great question. So I'm going to reemphasize the fact that the aircraft it's being certified to the same standards as any airplane. So anything related to safety, redundancy, or other factors, operational factors that get incorporated into the design, all of those features are going to be in Alice.
Perfect. All right. This attendee wants to hear more details about Alice, namely, how many flights has been made since the first flight, and what kind of performance has been tested? Have any problems arisen? And what's the current timeline for development and certification? That's a doozy.
Okay, no, that's okay. So the aircraft's slated for entry into service in 2027, which means that we'll have the type certificate. So it'll be an official plane that you can go and buy and fly. And so what we will be doing is we'll be scaling up our production line, in parallel to finalizing our flight test program. Okay, so that'll happen in that time period. So between now and the end of 2027, we're going to industrialize and produce the aircraft. To this date, we've flown the aircraft once. We've spent months looking at the data that was produced during that flight. The data matched the performance of the aircraft as predicted very, very well. And now we're working on what do we want to test next. Okay, so part of it is our focus right now is actually having flown the aircraft and shown that it works and being quite satisfied actually in our outcome. Our focus is on moving to the next steps of industrialization and actually producing the plane to deliver to our customers.
What is the operating altitude, and is the cabin pressurized?
Okay, great question. So we're designing it for a peak altitude of 15,000 feet. And again, I'll answer the question the way I think you're asking it. That means that you're going to be able to clear, most obstacles over any short range trip. And yes, it will be pressurized. The pressurization is going to be there so that, passengers and crew don't need to wear oxygen. But because it's 15,000 feet, and the pressurization is really only going to be used in those rare occasions when you climb, it's going to have a minimum impact on the structure and systems burden on the aircraft. I will add a fun fact. One of the reasons why we're not worried about the altitude for the aircraft is, again, short range trips. The electric motors are as efficient at sea level or even at the Dead Sea as they are at 8,000 feet, right? So there's no operational benefit to climbing from a fuel burn perspective. When you're doing your route planning, you'll actually keep the aircraft as low as you feel comfortable.
That's really interesting.
Yeah.
All right. How do you plan to train pilots on even the small differences between conventional aircraft and Alice?
We're going to partner with an established training organization for our training program. But the aircraft's, it's going to be a type rated plane because of its size. We've already gone through and trained a pilot to fly the aircraft, and that it's not trivial, right? So when we worked with the FAA to get our flight permit, we also had to do something comparable for our test pilot. So we actually have the basic standards that are required to train a pilot to fly an electric airplane already, and it's just a matter of rolling those out. We've had the conversations with training companies and with with the regulator. Again, going back to what we're doing here, it's a conventional takeoff and landing airplane, so it's really just a slight pivot in terms of the energy management.
All right. So most of this question has already been answered, but this one piece is and I'm not sure if I'm asking it correctly, but what is the single engine max ceiling altitude?
Sorry, say again.
What is the single engine max ceiling altitude? I'm not sure.
Max ceiling seat, like ceiling, like CEILING.
Yeah.
Yeah, so I guess the easy answer is it would be the same because the engine performance wouldn't be sorry. I mean, let me expound on that. What that question is asking is how high could the airplane fly with one motor operating, and without going into my flight dynamics team and getting them to actually calculate this, I'm going to go out on a limb and say that the aircraft's not going to be constrained by power. So it's it's being designed to 15,000 feet. So anyone can feel free to poke at that, but that's what I'm going with.
Okay, yeah. Awesome. And so the next question is, and I'm just going to boil it down, but the boiled down question is, do you see electrification occurring for long haul flights?
Okay, that's a great question. So we're an electric aircraft manufacturer. We've chosen our niche, again, our sweet spot in terms of what we're doing with the industry. Sustainable aviation is going to require really a mix of technology. So we're going to need electric, which is what we're doing, hydrogen, sustainable aviation fuel, and hybridization in any form. So we're going to need all of it to fly. For long haul flights or for flights with larger aircraft, there's no roadmap that gets you to a chemistry where you would be able to go and replace aviation fuel with batteries. Okay, so certainly not in our lifetime. So there are other ways that the industry is going to need to pivot in terms of fuel tech and other energy technology to get you a long haul flight. So again, what we've done is we've looked at the applicability of the aircraft and identified roughly 30% of the entire marketplace that could be serviced with an electric plane. So we're targeting on that.
Awesome. All right. Is the core business plan to fly point to point from the small airports to other small airports, or is the business plan to fly from a small airport to a hub? And
so it might cut out a little bit, but what I heard you say is our plan or is the business built around point to point travel between smaller airports or hub and spoke, so smaller airport. Yeah. The answer is it'll get used for both, right? So in our conversations with customers, again, without going into specific details, there are clear utilization cases for small municipalities to medium-sized municipalities, medium to medium, medium to large, small to large, right? You can actually look at multiple routes where they would where that would apply. To answer the question that will come up after that, which is, well, how do you get an electric airplane into an already busy airport? You know, they could, I don't know, I could pick any of them, but pick the busiest major airport near you. We've actually had discussions about potentially converting underutilized taxiways into a bespoke runway for aircraft like this, right? So add the capacity on the runway side, and that's actually not that complicated.
Awesome. All right, this one's very technical. What is the battery capacity, battery weight, and charging and discharging time? I think you already covered the charging discharging time. I don't think we covered. Well, we almost covered capacity, but I think weight was the last one we haven't covered yet.
Yeah. So the battery is going to weigh around 8,000 pounds as a design consideration, and then you can figure out the energy density and so on that goes along with it. But you know, we're looking at cell level energy density of about 375 watt hours per kilogram at entry into service, which we clearly see as being. I mean, honestly, you can get 375 watt hours per kilogram today. It's just a matter of making it industrialized and putting it into the aircraft application. So I'm guessing that's what you were looking for.
All right, a lot of these were already answered. You covered. Okay, I think this might be the last one because it might take a while. I'm not sure actually we want to tackle it. Okay, this one's probably been answered in your presentation, but we'll use it. Do you work with regulatory agencies to discuss updates to regulations considering changing technologies?
Yeah, so we've been actively engaged with the FAA in particular. We got really lucky. We were actually invited to testify before the Senate subcommittee on the reauthorization of the FAA a few months ago at the at the government level as well. So we've been very well plugged in with the FAA with advancement. Our primary contacts are with the innovation branch at the FAA, as well as the offices, the MITO and design offices here in the Seattle area. And we've had lots of discussion at the technical level and also discussion at the policy level as well in terms of how we can advance the industry. My main ask for the industry, for the regulators, and for the FAA in particular, is to really take the bull by the horns and become a leader in providing the standards for battery certification, right? So the detailed standards of how we're going to do it. In order to bring the product to market, I think everyone here, I'm guessing, understands the importance of making changes to the aviation industry so that we can continue to fly in a sustainable way. And what we need is for a global standard to apply. Often you get divergence in terms of technology standards across different regulatory environments, the FAA, EASA, and so on. We want them to be the same so that we can get our product and other sustainable aviation products to the marketplace as quickly as possible, right? It'll allow us to do more quicker.
Okay, now I think this one might be the last question. We might have time for one more. What are the specific FAA certifications you have received?
Okay, so we have our G1 issue paper. We haven't actually announced it yet. So we've got our requirements under Part 23, Amendment 64, with a couple of elements of Part 25 for the flight control system, as you'd appreciate, because there's currently no other Part 23 fly-by-wire aircraft. So that's what I will say in answer to that. What I said earlier is that it's an airplane. It's being certified as an airplane. That's in broad strokes what we've got back from the FAA is we've agreed what we're doing here.
Perfect. Okay, is there a modification of Alice which has a retractable landing gear to reduce drag during flight?
Yeah, the aircraft will have retractable landing gear for the. Yes, it does. Yeah.
Perfect.
We'll do one last one. Gregory, you're the champion of the Q&A.
Exactly. Let me, I'm trying to get one that we haven't. A lot of these are repetitive.
Well, hopefully that means that most people will feel that their questions were answered.
Yes.
Well.
Okay. How will this one could be an interesting one. How will Alice perform in cold weather operation?
Right. So the thermal management system for the battery will either cool or heat as required, right? So at different points in time, you either need to extract heat from or provide heat back into your battery to keep it operating at the right temperature. So again, it's just an airplane. So we have an operating envelope for the aircraft. The system's designed to manage the battery inside that envelope. I think that's the easy answer.
Perfect. And with that, I think it looks like we still have 90 Q&A questions. With that being said,
all together, but I think we'll cut it. We'll cut it at a high.
Tell them to come to the session on Thursday and
It's exactly you. Yeah, you took the words out of my mouth.
Yeah.
Apologies to everyone that we didn't get to, but it's fantastic that we even got to the majority of the questions, and they're actually still coming in. If anyone is interested in connecting with Greg, either use the QR code here on the screen. I also put Oscar's contact info in the chat. Feel free to write him directly, and if relevant, we'll put you guys in touch directly as well. And obviously, just like Greg just said, this Thursday, there's also the Aerospace and Defense Showcase, which I've also posted in the chat. I'll post it again in a second before we log off, where Eviation will be presenting again, along with other key members of the aerospace and defense industry. That'll be this Thursday at 1 p.m. Eastern as well. And we like to keep these sessions short and sweet so that everyone can have an amazing day afterwards. So thank you so much, Greg. We appreciate it. And this was fantastic.
Yeah, thank you very much, Ashley. Well, thanks for hosting. Really enjoyed this, and thank you everyone who came, and especially those who asked questions. That's always the best part. So, thank you very much.
Fantastic. So we'll leave the event on just for a few minutes. If anyone wants to copy any links, I'll repost a few things in the chat. So if anyone wants to visit or get in touch, just take a look in the chat. I'll send everything right now. Thank you to everyone who joined.